Hi, my Algebra 2 students. Today is day 4. We are looking at horizontal dilations. So yesterday was vertical, today's horizontal. So this first example really just kind of shows you how a horizontal dilation works. So I've started by graphing the function that was given to us here. That's the f of x equals absolute value of x minus 2 and then minus 3 over the domain from 0 to 4, which means endpoints on it. So I'm going to slide up so you can snag my values here if you need to. At 0, it's -1, and then -2, -3, -2, -1. Feel free to pause the video if you'd like to get all that graphed. Right? So that is the original function. Now it does say sketch with a solid line. I like using colors better, so I'm going to use blue for this first one, but you pick. All right. If you don't have colored pencils, then stick with the solid line. For the second equation, it's saying g of x is going to be equal to f of 2x. So let's calculate what that would look like. So if we do f of 2x, you know that means we're just dumping 2x in place of where x was before. So that means 2x will go right there. And that's really your only change, right? So that is going to be the g of x function. So sticking with my colors, I'm going to make this in red, right? So if I put that into the calculator, it does stipulate that you're going to do something a little different here. So it's saying for g of x, you're going to just graph it for the domain from 0 to 2, and you have to change the window so that the change in values goes up by 0.5. So let me show that here. So into y2, I'm going to put the function. So remember, it's math and then over to absolute value. And then I'm going to put in 2x minus 2. And then outside of that, minus 3. Right? But then under window, if I click on window, I'm going to see if I can zoom in a bit here. Or excuse me, not window, above window. So hit second and then window. There we go. I still want it to start at 0. That's fine. But then change in table, change that to 0.5. So it's going to go up in increments of 1/2 now. So when I go back to the table, it goes 0 and then 1/2 and then 1, then 1.5. All right. And now I want to read specifically the red values over here. So at 0, it's -1. So let me slide this into view here. So 0, it's -1. At 1/2, it's at -2. At 1, it's at -3. At 1.5, it's at -2. And then at 2, it's at -1. So we're changing the increments for the x values on the table. Right? And then we can plot that. So onto your graph, let's come back up here and plot those values. So at 0, it's -1. At 1/2, it goes down to -2. At 1, it goes down to -3. And then at 1.5, it's back at -2, I should say. And then at 2, it comes back up to 1. So you have this really skinny little graph right here. That is g of x. All right? That's what that graph should look like. All right? Now you have to do one more. So let me zoom back out so you can see a little bit better. The last one is asking you to do h of x. We're going to make that equal to f of 1/2 of x. So you know what that means. Go back to the original function. Wherever there's an x, we put a 1/2 x into it. So it's going to look like this. So this is equal to h of x, this guy right here. Okay, into the calculator. So I'm going to get rid of my second one, and I'm going to put this in place of it. So math, absolute value. So arrow over to number. And then I'm going to do 0.5x minus 2. Oops. I put in -5. Try that again. 0.5x minus 2 and then -3. If you type in 1/2, it'll work just fine as well. And now this time it says you're going to graph it over the domain from 0 to 8 in increments of 2. All right, so go back and I'll zoom in a little bit here. You're going to look in the table. So second and then window. So second window gets you to the table settings. I want it to start at 0, but now I want it to go in increments of 2. So you're going to change that little triangle table or delta table is what it really is. And now go back to the table and it jumps in increments of 2. So 0, 2, 4, 6, 8. So coming over to my red. So at 0, it's -1. At -2, or excuse me, at 2, it's -2. At 4, it's -3. And then at 6, it's back to -2. At 8, it is -1. All right. Because I don't want you to forget about this later, right now, go back and switch that. Go to second table setting, and I want you to change it back to delta table as just 1. This way in the future, you'll be all set. All right. So let's come back to the table. So we should have -1, -2, -3, -2, -1. All right. Plot those points. Oops, a little too zoomed in there. All right. So at 0, you start at -1. Over to 2, it goes down to -2. At 4, so here's 4, we're down to -1, 2, 3. At 6, we are at -2. And at 8, you're at -1. All right, if you have a straight edge, it's helpful. Otherwise, do the best you can to draw this in. I'm going to go over it in highlighter just so you can see the difference. And that is our h of x function. But what should be becoming very apparent is that the graph is either getting squished in or stretched out, but this time in a horizontal direction. So let me go over that here. That's our h of x. All right. I'll kind of highlight it over here as well. All right. So when you look at this, it says use your calculator. Oops, just kidding. We did all that. Down to step 4. Determine the turning point. I really hate that term. Determine the vertex. I don't know why. I just don't like it. For each function. So for f of x, there's your vertex right there at 2, -3. For g of x, that's the lowest point. It's 1, -3. And for h of x, it is at 4, -3. So what we should be noticing about all of these, for all of them, the y value does not change at all. So when it says conclusions, that's the first thing I want to conclude, that the y value doesn't change. We kept getting the same y values over and over and over again. What does change is the x value. So let's look. If I look back here, this is f of x. This one was f of 2x. This is f of 1/2 x. So take a look at the x values. It starts at 2 when it's plain old f of x. Then it goes to 1 when it be do f of 2x. Then it changes to 4 when we do half of x. But you always want to be thinking back to the original. So from the original to the second one, 2 gets cut in half to go from 2 to 1. 2 gets doubled when we go from 2 to 4. If you look at what the rule was, it gets cut in half when we double here, and it gets doubled when we cut in half. So the connection is that it's always the opposite, essentially, of what you're looking at. So what we mean by that, right? The x values change by doing the opposite operation. So for f of 2x, we ended up dividing the x by 2. For f of 1/2 of x, we end up multiplying the x by 2. So it's really important to note. If I see 2 times x, you're really going to do the opposite. You're going to take x divided by 2. If you see 1/2 of x, which keep in mind can be written like x over 2, that would be the same as multiplying x by 2. So anytime you're inside with the x's, they really always end up doing the opposite of what you would think. Even going back to the translations, you shift left or right depending on the plus or the minus, and it always seems to be the opposite of what you'd expect. Right? When we flip on over to the next page, let's kind of capture that in the little chart at the top here. So when we are horizontally dilating, saying given the function f of x, if you have f of k times x, where the k value is greater than 1, right? When it's greater than 1, what's going to end up happening is you end up seeing it shrink. It does the opposite of what you might think. So this is a horizontal compression, which really means it's going to be narrower than f of x was. You're going to kind of see like a little shrink, or it's going to smush together. Whereas when we have a value between 0 and 1, like a half or a third, it's actually going to stretch out. So this is going to be a horizontal stretch. Which essentially makes it wider than f of x. And it might take you a little bit to like wrap your brain around this one. It's definitely a little tricky. So let's copy the same thing that we did from the last page, that it does not affect the y value. And so the y's don't change at all. When it's a horizontal dilation, it only affects the x's. And how it affects the x's, the rule is that you're simply going to divide the x value by whatever k is, right? That is going to be our rule here. So hold on to that thought. With that being said, let's take a look at a few things. So the first one, you're given an f of x function, so x squared minus 12x plus 20. Use your calculator to determine the vertex. It annoys me. Determine the vertex. All right. To save us a little bit of time, I can do it on my calculator. Unless you want to do it with me, that's fine too. But if we go x squared minus 12x and then plus 20, I know for a fact that you're going to have to change the window. So I'm going to change my window right down now to make my y minimum negative 20 so that you can actually see this thing. So let me graph it for you. And there we go. All right, so the vertex, that's that point way down there at the bottom. You can calculate it by calculating a minimum, or you can go and look in the table. It only is going to show up in the table if it's a nice whole number, so just keep that in mind. Otherwise, second, trace, min, and then you can follow the prompts. It's going to ask you for a left bound, right bound, take a guess. So it's a good time to show you this just as a little reminder. Slide it on over, and there we go. So the minimum comes out as 6 with some decimals, but really it's 6 comma negative 16. So that is the vertex point right there. All right, so my vertex is 6 comma negative 16. Okay, if g of x is defined by doing f of 3 times x, find the formula for what the new g of x function is. All right, well, f of 3x means take your f function, and wherever there was an x, so that's here and here, we put 3x in. So if we do that, that's going to be 3x, that quantity squared, minus 12 times 3x, and then plus 20, right? This quantity, don't forget, square the 3 and the x is 9x squared. This would be minus 36x plus 20. That would be my g of x function. And then it asks, what is the turning point or the vertex of g of x? Well, I can find it one of 2 ways. Let's talk about both. One way would be to take the vertex up here and talk about what should have happened. So the vertex originally was the point 6, negative 16. If we do f of 3x, all right, so when the number in front is bigger than 1, that's going to be a compression. And you're going to divide the x value by whatever that number is. So I would take the x value and divide it by, excuse me, the 3 there. So based on that, this should now be the point 2, negative 16. So if I trust the rule, that should be it. My other option would be to go to the calculator and actually try it out. So I can type in 9 and then x squared minus 36x and then plus 20. And let me graph this guy. So the original's still there, right? Notice the graph. It's narrower than the original, which is what we would expect. And the vertex point shifts over here. So it still stays the same depth at negative 16. But if I calculate the minimum, let's see if it'll, oops, let me hop graphs here. So there's my left bound, there's my right bound, take a little guess. And it's now telling me, if you zoom in kind of, it's got 1.999, but we know that's the calculator trying to tell me it's 2, negative 16. All right. So keep in mind, g of x is a vertical, or excuse me, horizontal, whoops, compression by a factor of 3, right, of f of x. And so we end up with that whole graph getting kind of smushed and narrower on the x and y axes here. All right. We have one more graph to look at. I think that might be it. And then after that, it's going to be some practice that I think will save. Possibly, I got to double check. So this one, it says, given the graph of f of x. Okay. Here's this guy. They're saying if g of x equals f of 1/2 x for all values, graph it and see what you end up with. All right. Well, for this one, let's think about a couple things. If we have 1/2 x, that means that instead of cutting the graph in half, it's going to do the opposite. So it's going to be getting wider, or kind of doubled the horizontally here. So the rule technically is to divide all the x values by 1/2. But if you divide something by 1/2, that's the same as actually multiplying it by 2. Whew. So with that being said, the graph should be wider horizontally. So it's a horizontal stretch. All right, let's make that happen. So I'm going to take a look. If I look at my x values, I'm not even going to write down my y values, partially just because I'm being lazy. So if I take the x values from the original, we are at -3. We are at -1. We are at 1, 2, 3. And we are at 4. All right, let's talk about what should happen with all the x values. So they are simply going to get divided by 1/2, which is the same as multiplying them by 2. So -3, that's going to move on over to -6. This will become -2. Multiply that, becomes 6. Multiply that, becomes 8. So the y values stay the same. So this will now be the point -6, 1, 2, 3, 4. So that guy stretches that way. This goes from -1, -2 to -2, -2. So it stretched out a little bit. This one goes from 3, -2 out to 6, -2. So it stretches that way. And then the last one, 4, 3 goes to 8. I think 8 should be down here. 3. So it extends that way. So now when I graph all this together, I can connect the dots here. It literally looks like you took that funky little graph, got your hands on it, and just stretched it apart. So when it says evaluate each of the following, well, these aren't too tough to do. -6, right, is still at the y value of 4. -2 is at -2. And then over here, 6 is down at -2 as well. And then 8, you're up at 3. So I could have actually done the whole table of values and shown that the y's stay the same, but I just showed the x's since we know, and I can mark that here, that the y values stay the same. All right. On to the back. On the back, I think we're going to save maybe that first example 3 as a little recap to start off class tomorrow. And then the rest of the page is actually some practice. The rest of the page doesn't have anything to do with horizontal dilation. So it has to do with an increasing or decreasing function. This one has to do with translations. And the last one has to do with the reflections. So let's keep that last page as a little recap here to be able to start off class tomorrow. Thanks, guys, for watching. Don't forget to answer the post video question.